Just a quick video on fertilizers, since it's part of the chapters on soil management and the chemical properties of soil. So we know there's two types of fertilizer. There are straights and compounds. Compounds usually containing the macronutrients NPK, nitrogen, phosphorus and potassium, and sulfur a lot of the time. So just an example of a few fertilizers here and their uses. 18612 plus sulfur, that's what the S stands for. 18 units of nitrogen, 6 units of phosphorus and 12 units of potassium, and it has sulfur in it as well. That is an example of a compound for spring barley, growth. Sul grow here, just meaning it contains sulfur again. 23, 2.5, 10, 23 units of nitrogen, 2.5 units of phosphorus and 10 units of potassium. That would be a common silage compound, or in my case I'll be using it for winter cereals, topping up winter cereals. 10, 7, 25, we know that this fertilizer has a much higher level of potassium than most fertilizers, and because of that it will go on soils with an index of 1 or 2 for potassium because of the low potassium levels. It depends on your soil type of fertilizer you use, and this suits the best. So you can see here it's made up of ammonical nitrogen and nitric nitrogen, meaning that it is nearly immediately plant available. It doesn't have to go through the nitrogen cycle much. I think the rest of that fertilizer, that's just 18612 again. I think that's all. 10, 7, 25. Other types of compounds, we have a couple of different compounds over here again. This one here is another one for spring barley. It's a 13-5-25 for ground that has a lot of phosphorus in it. It doesn't need as much phosphorus, so that's why there's only 5 units of phosphorus in the soil. But this is a bit different. This is, as you see here, it has ammonical nitrogen and ureic nitrogen, meaning that this actually is a type of urea nitrogen that has to go through the nitrogen cycle, and there is a risk of volatilization. Now the only thing is, I think, not certain, but I think that is protected urea that's in it, so it should be safe from volatilization. Same kind of fertilizer again. That is another example of fertilizer, a straight this time instead of a compound. It's 38% N plus 7% S, which is your sulfur. You can just see it here, it's urea, so it has to go through the nitrogen cycle before it becomes plant available. Here, everyone knows this one, I've all heard of it before. 10, 10, 20, 10 units of nitrogen, 10 units of phosphorus and 20 units of potassium. And at the back here we have 26% N plus 4% sulfur. That is calcium ammonium nitrate. It is plant available straight away. It does not have to go through the nitrogen cycle the same way as urea. Now I think as well, I'm not fully sure, but I am fairly certain that that urea there, that 38% urea, is protected urea. While if you come over here, there is 2 more pallets of a different type of urea. It is, it's very hard to get the label out here, but if we can see it there. That is 40% in. So just see there in that label. Hard to see it there, plus sulfur, but that is not protected, definitely not protected. And that urea, if you don't spread in the right conditions, such as dry weather, can suffer from volatilization. Finally, another example of a compound in here, 0,730, no nitrogen, 7 units of phosphorus and 30 units of potassium. The reason I have some of this is for beans. Beans make their own nitrogen, so they do not need nitrogen in the soil, and because of that we use a compound like 0,730, no nitrogen required, and that would be the reason for it. So that's kind of all the fertilizers. A couple of examples there. A compound with no nitrogen, you have straight normal urea, you have 10, 10, 20, you have CAN, we have 13, 5, 25 made with urea, we have protected urea, we have 18, 6, 12 plus sulfur, 23, 2.5, 10 plus sulfur, 10, 7, 25 plus sulfur. There's plenty of different types of fertilizer, and you always base your fertilizer use on a soil sample.